so now that we have our paddle moving, let's get our ball moving at the same kind of time. So we'll go to our ball here. We've already given it a circle collider, which is perfectly fine, but now we need to give it a rigid body so that we can apply physics to it like we did previously. So we're going to go physics 2D and add a rigid body 2D, just like that. We're again going to set our gravity scale to be 0 because we don't want this ball just magically falling down by itself. We want it to bounce off our paddle and bounce around between all the various bricks in the world. And the next thing we want to do is go ahead and create a new script that will control our ball. Now we're not going to reuse the same script we did last time because we're going to do some different things with our ball controller script this time, but we are going to create this script and call it again ball controller. While that's compiling there for a second, we also need to remember that we need to apply the bouncy material that we made last time in our previous project. So we're just going to go ahead and make that again. So we're going to our materials folder, we're going to right click and create a new physics material 2D. Again, we'll call it bouncy, and again we'll set the friction to be 0 and the bounciness to be 1. So perfect. And now we'll go back in here and we're going to open up our ball controller script, and we're going to set a current or a couple of simple little variables that we're going to use to control our ball. So what we're going to want to have, we want to make sure, because our ball will be bouncing around from side to side a lot more whenever it hits against bricks and stuff like that, we don't want our ball to be able to go too fast. So it could happen that our ball would start jumping around like crazy. We don't really want that. So we want to limit the amount of speed that the ball can have. So we're going to use a public float that we're going to call max horizontal speed, like that, and then we're going to use that to limit how much our ball is moving within the world. But of course, for our ball to start moving at the start of the game, we also want to be able to give it a certain amount of speed to start off with, and that'll be another value that we're going to use called public float that we're going to call vert speed. So that'll be how fast the ball will start moving in a vertical direction. And much like we use in our previous project, we need to be able to apply this speed to our ball to start off the game. Because when we start, we need some actual action to happen, not just for it to kind of float around there doing nothing. So we're going to need to access the rigid body that's attached to the ball. So we're going to create a new private rigid body, much like we did in the previous project, rigid body 2D, and instead of calling my rigid body, we'll just call it the RB, nice and short, for the rigid body. And then at the start, as soon as the game starts, we're going to say, okay, the RB should be equal to get the component that is attached to the same object that this script is attached to, and the component we're looking for is the rigid body 2D component. So that'll find the correct component that's attached to the rigid body, and it'll make sure it's applied to this variable. And then the next thing we want to do is, as soon as the game starts, we want to say, okay, set the velocity of this ball, so the rigid body dot velocity is equal to a new vector 2 that will say it'll start out moving at vertical speed, and it'll start out moving at whatever we set to be the max horizontal speed. So we're going to save this, and we're going to pop back into the game just to see this in action, and then we're going to make sure that we set that in our game. And so, as I said, the reason we don't want to let it go above a certain amount of speed is, say if our ball was coming down at this angle and it hit our paddle, and our paddle then was moving to the right, then we start making the angle shallower and shallower. At some point we could end up with the ball kind of moving almost horizontally, just kind of bouncing back and forward, and that's not going to make our game very fun. So that's why we want to make sure that our horizontal movement is constrained to be a certain amount, that we can't affect it too much. So now that that's finished compiling, we're going to go to our ball, and then we're going to add the ball controller script to it. So I'm going to start typing ball, there we go. And we're going to need to decide how much speed we're going to give to it. So we're going to keep it nice and simple and just kind of use let's say, we'll say just 5 for both values, nice and simple. And we're going to hit play, and we'll see the ball go up. There we go. I haven't given it the bouncy material, I just realized, so that's why it's not really being very helpful. It's just kind of flapping around a little bit. So let's change that and give it the correct material in a circle collider, and we'll start going again. And now we should get, there we go, the ball bounces off just the way we want it to, and now we're able to bounce it around like this. So as you can see, now I'm starting to make it move from right to left a lot more, and it's getting a lot faster, and it's making it a lot harder to control, and which will just end up being really unfair on the players. It gets out of control and you can't really do anything with it. So as I said, we want to constrain the speed of the ball as it moves from side to side. So what we're going to do is just add a couple of simple if statements into our update loop here. So we're going to say if the rigid body velocity on the x-axis is greater than our maximum horizontal speed, then we want to set it so that the rigid body velocity is equal to a new vector 2 which has max horizontal speed as its x-axis, because we don't want it to go any faster than the max horizontal speed, and on the y-axis we're going to leave it alone at whatever speed it's currently going at. So the rigid body velocity dot y. Oh, and hit our semicolon at the end. And then after that we want to say else if, again, the rigid body velocity dot x, if this time if it is less than minus max horizontal speed. So we have it currently set that max horizontal speed is 5. If it is less than minus 5, so that's when it's moving to the left. Well, if that is true, then what we want to do is do the same bit of code we just typed here. If I could highlight it properly, paste it back in there, and instead set the vector speed to be minus max horizontal speed. So we can save this, and what we can do, much like we did previously, is to make sure that our debug.log is telling us what the current speed of the velocity is. So we used debug.log before for when our ball stopped colliding with the paddle, but we're just going to have it running constantly when this script at the moment. So we're going to say debug.log the rigid body dot velocity. Let's save that, and then we should see when we go back into the game, we should be able to keep track of what the velocity is doing at any particular time. So it's finished compiling, we can play and keep an eye on the numbers at the bottom. You can see we're never going above, so I've slowed the ball down there. Oh, well, I just lost the ball completely then, but you can see I was able to slow the ball down. We saw the change in the velocity. I could then speed it back up if I wanted to by manipulating the direction. There we go. See, I've slowed it down more. I slowed down even more by making it go the opposite way. And as you can see, we're slowing it down like that. So let's speed it back up again and slow it down. You can see we're making changes to the velocity of the ball, and that's exactly what we wanted to be doing. But if we speed it up, no, I managed to miss that one. We can't speed it. I missed it again. But we can't speed it above the maximum horizontal speed that we have set, which is perfect. That's exactly what we wanted to do. We don't want the ball to get too out of control. Now, you don't necessarily want the maximum horizontal speed to be the exact same as the vertical speed. So say, for example, what we could do is just set it, as soon as the ball starts, it actually uses the vertical speed on the x-axis as well, like that. So we have our ball traveling at a constant speed once it's first started, but back in the game here, that means we're still able to have it go faster once the game is being played. So say if I set this to be, say, 8. So now if we go into the game, once things start moving, our ball goes like that. And at the moment it's going to 5, but if I can speed it up, there we go, it's starting to go 7 there. So our game now is a little bit faster to play, but it's not unreasonable, it's not unmanageable. And again, it's about finding the balance between these things, and that's only going to come with your own testing and feeling the game out for yourself and feeling how it feels. So, but we've successfully now controlled the speed of the ball, and that's what we really wanted to do.